Welcome, AP Statistics. I hope that your Thanksgiving break has been a slam dunk. I hope it's been a great time. Hey, I'm actually over Thanksgiving break, and I wanted to shoot some podcasts to you for multiple reasons. But one of the main one is my wife is pregnant, and eventually she's going to have the baby, and I wanted to make sure that you're prepared. And so the podcast that you're going to watch, starting with this one, this first one's maybe not as much for that reason as much as just hopefully allowing you to have just a little bit of a reminder before you headed into the week of test week, with the test being on Friday, the end of this week, over Chapter 6. So I wanted to start with just a quick reminder, and because we always do it, I made it for the first time. Gotta love it. But hey, I hope this is helpful for you. I wanted to run some podcasts for you here and make sure that we went through it together. And so here we go. Remember in 6.3b, we started on this on the Friday before we broke for Thanksgiving break. And what we did was we went to, we had this idea of what is a binomial distribution. And we said that with a binomial distribution, it's one in which has a couple of conditions, right? And it would be BI and an S. B meaning binary, meaning there's a success and failure. I is independent, which means one does not affect the other. N is a set number of trials, right? And S is one in which there's the same probability, right? So we call this bins, same probability. And what we did was we noticed that up here, we had the scenario where each team would get 5 players to kick penalty kicks. And we're just looking at the GAC girls, so just the 5 in which they kick, with the 60% probability. Well, a couple of things. This shows us that this is, in fact, a binomial setting because you either make or miss, okay? One kick does not affect the other, meaning it's independent. The set number of trials is 5, and each has the same probability of 60%. So within this, we would say BIN and S would be the bins distribution there. Now, let's say that we were trying to find what is the probability they would score on 0. We had 2 ways that we could find this. The first of which is, first of all, we know that if I were to write this, this is the probability of our value equaling K, right? And K in this case would be 0 or 1 or 2, and we would keep going so on and so forth. Now this formula we gave in section 6.3a, and so you have it. I just want to make sure you realized it, where N is the total number. So if I was looking at this one, we'd put 5 in for little n, wherever we see little n. For K, we plug in the number of successes, which would be 0, 0 makes. And the probability would be 60%, so it'd be 0.60 in for P. And so we would plug those in and go from there. This is the formula that you'll have on your formula sheet. However, if you went to, and by the way, this represents the amount of combinations. I forgot to mention this, but NCK, another way of writing this would be N over K, like this. This would be like the same exact thing. And so don't let that confuse you come test time. Another way that we could write this is binom PDF on our calculator. So this is on our calculator where we go to second vars. This is strictly on our distribution that's here. Sorry about that. Someone's calling me. And what we could plug in is binom. So we have to do this if it's on an FRQ, right? You have to establish context. The PDF you use in this case, because PDF is one value, whereas CDF is that value and anything less than. And I'll show you that in a second. But binom PDF, little n would be 5, probability would be 0.6, and then we have comma 0. So I would write this as well as this on an FRQ that's there. Again, PDF means one value. I'll kind of write that up here. PDF is the one value. So if I were to just keep plugging this in, I could, except on my calculator, I would put at the end, the only difference would be 1, 2, 3, 4, and 5. Okay? Very nice. Very good. So we'll plug in that, and we get the following probability of 0.01024. I'm just giving this to you just so you could see it. 68.2304. And again, I would plug this in my calculator to get this out. So this is this one would be the probability, and this is how you interpret it. The probability that the GAC girls will hit exactly 4 out of 5. And to get 5 out of 5 would be 0.07776 there, okay? And that's how we plug it in. All right, let's go to the next thing. It says, this is the new part here, starting at 3 going downward. What is the probability, or find and interpret the mean of the probability distribution? Well, I'm giving you the formulas here, both for the mean and standard deviation. And again, this is of a binomial distribution. So the expected value would be n times p. So that would be 5 times 0.6. So again, formula plugging in, the answer obviously. So let's do that right. Oh, I'm sorry, 3.0, right? So 3 is my mu. So mu is equal to 3. And so what we would say is after many shootouts, or sampling many shootouts, we expect the average number of goals made by the girls team of GAC team to be 3 out of 5 attempts, okay? So that's how you would interpret it here. Very similar to what we did earlier. The big thing is just remembering the formula for a binomial. Now, onto the standard deviation. The standard deviation is n times p. Well, we've already done that, which would be 3. But then we multiply by 1 minus 0.6, which is our, this is the failure. So 3 times 0.4 with the square root would be approximately a standard deviation of 1.09, okay? So we would say we would expect, we would expect the number of goals, sorry, getting too quick, to vary typically by 1.09 from my mean. Right? Average distance from the mean, same idea. I see this interpretation more on the binomial side, so that's just a heads up there, okay? So again, these are just the formulas that you would need, so make sure you get those down. Now the last thing is, what is the probability that the team scores at least 1 goal? Well, at least, right, the probability of at least 1 is equal to 1 minus the probability of none, or the counter of whatever we found there, if we say at least. So the probability of none, going backwards, again, very similar to what we did earlier, was 0.01024, 24, my fault. 1 minus that would then equal 0.98976. So the probability that they would score at least 1 goal would be 0.98976. Again, the reason why is the probability of none is the counter of that, and then 1 minus that is like everything but those that scored none. You could also come over here if you had this and just add 1, 2, 3, 4, and 5 together, because at least 1 would be the probability of all of those wrapped together. Okay, number 6. Now here's the kicker. If the other team is expected to make 3 goals, okay, what is the probability the GAC girls team wins, not ties? So in order for this to be the case, we have to find the probability that they score 4 or the probability that they would score 5. Now, these are mutually exclusive. You can't do 4 and 5 at the same time. So we would simply just add what is the probability of getting 4 plus the probability of getting 5, okay? So what would that equal? Well, after I do this, I would back up and say, okay, that'd be 0.2592 plus, sorry, come back here, 0.0776. So here we go. Okay, is that 3 sevens? Yeah, perfect. And then once I add these two together, I get 0.33696. This is a great FRQ question, especially from that binomial that's created. And that would be that'd be really good, something really good to go over. The only other thing that I would say is you could also do binom CDF. And just like before, I would put in NPK. And what this does is this allows me to find the probability of not just one value, that's PDF, but whatever that value is for K and anything less than. So if I did binom in this illustration, CDF, 5, 0.6, this would be 3 or anything less than 3. So I would put 3 here. This would get me 0.6, I could be off a little bit, 304. I could be off just a little bit because I went backwards. Because this is 3 or anything less than. So if I wanted to find anything greater than, I would just do 1 minus that to produce the value that you find here. So there's really multiple ways of finding it. I just wanted you to see the CDF in comparison to the PDF. All right, get this down real quick. This is our golden nugget. Good stuff here. It allows us to kind of see just what we just talked about. Make sure we distinguish between each value. You'll notice here, I'm just writing down both formulas. K, or I'm just putting this down so you can see it. And then binom PDF is just the value. Okay, perfect. Okay. So make sure we get that down. The interpretations, make sure to say that out of how many trials, right? Because it's important that within a binomial, it has a set amount of trials. And so you want to make sure you put that down there as well. Freeze that or go back to that if need be. And then also with the check your understanding, this would be a really good one just to kind of double check on, maybe a good one before you come into class on Monday. And that way you've had a little bit of background there. And then here's your answers to the check your understanding. Check those out. And there you go. Gotta love it. All right. Other than that, I hope that was helpful for you in attacking everything before Thanksgiving. Again, you're going to look at podcasts, especially when my wife goes into labor. I'll be out for about a week. But I'm going to hopefully allow all of our classes to just continue, kind of flow through. And that way it doesn't stop. Does not stop. Hey, I appreciate y'all. Know I'm in your corner helping y'all out. And eat a lot of turkey for me. Bye.